questions, but I definitely don't mind. And always start with homework questions, then go to kind of, review of what we've done recently, and then new stuff. So thank you, Cindy. So we're going to start hearing of this difference quotient several ways. One is a difference quotient. Two is average rate of change. And then eventually something called a derivative. Okay? But it's really all relating to that same idea. So I want to pick a difficult problem from homework 6. I think I have that here. Give me 1 second. Yeah, homework 6, difference quotient. And just do a quick problem that will recap last week. How'd you do with it? I know there's one problem that was tough. It's probably this one. So, anybody get number 4 in the homework? I don't have my screen up for a second here, so anybody get number 4?
Yeah.
Yeah? Wow. That's good.
It was a little difficult. I had to do an example.
Yes.
For a little.
Yeah. My teacher might hit the button. My teacher sucks. Show me how to do this. Yeah, I get it. So this one's pretty difficult. I think I would like to always see the graph. Whenever someone gives you a function, even if you were at College Park, you would say, I want to see the graph. I'm going to hide my calculator during the lecture or work on it at home kind of thing. I know they don't allow calculators on tests or quizzes, but it doesn't mean you can't look at something when you're practicing. And this is the key. It's like if you were learning guitar, you might put little stickers on the frets. Or if you were learning dancing, you would put a little footprint on the floor somewhere. And so this is not a bad way to learn, just not acceptable usually when you're testing. So I've got y equals, what did I show? 5x divided by, and I forget already, x plus 2. So that's the problem I'm looking at. And I'm looking at, I'm looking at that particular curve. I'd like to be able to find a secant, the slope of a secant line through any 2 points. It doesn't really make a lot of sense to pick points on 2 pieces of the curve. It kind of makes more sense to pick points on, parts of the curve that are connected. So it looks like I'm probably going to pick 0 and 8 as my x values, just because I want to. And so if I plug in 0, what do I get? For my answer, I get 0, 0, right? If my x is 0, I get y is 0. And I can see a nice clear point on my curve there. And I can also see that, well, at least I think 5, 6, 7, 8. If I pick 8, it looks like I'm hitting at a vampire point. It's just a coincidence there across here, right? So if I plug in 8, I should get what? 40 over 5? Is that right? No. 8 times 40 over 10, so 4. Is that right?
Yeah, that's 4.
Yeah. If I plug in 8, I should, yeah. So I'm going to plug in 8. So if I plug in 8, I get 8 comma 4. And this is one of the things we're talking about today is like just does a point exist on a curve, that type of thing. We're talking about graphs of functions today. And I want to connect those 2 points with a secant line and find the slope of that secant line, right? And of course I could do all that by hand, right? So what do I have? I have f of x equals 5x over x plus 2. And I had gotten to 0.00 and 84, right? And of course, all I would need is y equals mx plus b to get that equation of the line. I know b is 0, so all I need is the slope. What do I get? 4 minus 0 over 8 minus 4, I get 1/2, correct? So my equation is y equals 1/2 x. Is everybody okay there?
Yes, sir.
Anybody not okay there? And that's all right. You can chat it to me. How'd you get that? So there's my secant line. So I'm going to just verify that my difference quotient gives me the same slope, right? How we doing? You okay? I love Monday energy is my favorite. All right, let's see if we can find the difference quotient. Thank you, Brian. Appreciate that. So, difference quotient. I'll call it dq, and I'll say 5 times x over x plus 2. That's my function evaluated at x plus h, minus the original function, all over h, right? So you can see that purple piece is where I'm really trying to manipulate. And I use open parens first, and then I plug into my x plus h. And it really helps to do this. I like to use implication arrows, not really saying equality. There's some sense of equality in that symbol. You can see it. But it's really, it's leading to my next result. And so I'll distribute everything. I get 5x plus 5h over x plus h plus 2 minus 5x over x plus 2, all divided by h. And here is where I want to wrap multi-terms, you know, not in like a in M&N sense. Just anytime I see multi-term numerators or denominators, I'm going to put them in parentheses, right? I'm trying to now figure out the common denominator, and the easiest way is to multiply by interior denominators. So I will have an x plus 2 and then an x plus h plus 2, and I'm going to multiply the whole thing by that over itself every time when I have a fraction, when I'm working with a difference quotient with a rational expression. How we doing? Thank you, Ryan.
Very good.
Thank you, Wilder. Thank you, Jamal. Oscar, Yvonne, nice. Daria, thank you. Jarrett. So I'm going to try and keep my original function in black. And remember, I'm not going to worry about saving paper. I don't care. So my original function is in black, and I'm going to distribute with the red, right? So I can really see in my next line. And think about what I did. I didn't do anything mathematically, right? I mean, maybe there's this aspect of distributing, but I didn't actually distribute yet. I just rewrote it, right? And before I go further, I'm going to try and cancel. So I can see my x plus h plus 2 will cancel here. My x plus 2 will cancel here. And I really find it helpful as I'm looking back on something if I use a different color. I know you have to really be a nerd to to go to that level, but it's not a bad idea really to think about accepting your fate. So now I'm rewriting 5x plus 5h times an x plus 2 minus 5x times the quantity x plus h plus 2 all over h times x plus 2 times x plus h plus 2. Elise, you see anything yet of something that is clearing up about what you had trouble with it?
Yeah, I think the main issue that I had was that it just was like a very large problem. Like once I got it, I realized it was super easy, but
Yes.
I was like, oh,
Right.
it's like a fraction on top of a fraction.
Exactly.
And it scared me.
Yep, exactly. Yeah. I have a half brother that scares me sometimes too, but you know, we got to get over that. So now you can really see that everything I've done along the way is so simple, and I'm just trying to stay organized and clean and neat about things. And I don't care how many pieces of paper it takes, but now I'm going to start to distribute here, right? I'm going to distribute here. I'm going to distribute here, and then the negative. So I'm taking my time on all of this. I get a 5x squared. I've got a 10x. I've got a 5hx. I've got a 10h. I've got the opposite of 5x squared plus 5hx plus 10x. And rewriting again the denominator. And I know what you're going. You're going, I got things to do. I don't want to do this. But right now, this is your job. So I'm going to distribute the negative. I can get a little lazy on this because I know terms without h's in them should go away. So I know the 5x squared should go away. I know the 10x should go away. And it doesn't have to be that an h term can't go away. In fact, you will see here that the 5hx does go away. So now the only thing I have left is 10h over all of this stuff. So now I can clearly see that the h's will cancel, which is good. Remember, if I don't have an h term, if I don't have h terms upstairs, I'm in trouble. So, but I do have it. I have my difference quotient now. I've got 10 over x plus 2 times the quantity x plus h plus 2. And there's the difference quotient. Now, we already realized when we did the original problem, right, that we got a slope of 1/2. So, and you know, I know I'm going back to the first part of the page, but if you need me to go back, right, remember you're paying for this. So, but I can see that I picked an initial value of 0 for my x's, right, and so I want to think of x as 0. I want to fix one of these points as the point of interest. And I want to now see if the difference quotient will give me the same result. So if I let x be 0, I have to figure out what h is, right? So what is h? So how much further is my next x? That's my value for h, right? So h ends up being 8. And so, by the way, delta x is h. So if I move to the right, h is positive. If I move to the left, h is negative. How are we doing here? So I want to see if my difference quotient gives me a slope of 1/2, right? So I'm going to take my difference quotient, and everywhere there's an x, I'm plugging in 0. And everywhere there's an h, I'm plugging in 8. Sorry, 8 plus 2, right? So it looks like I get 10 over 20, which is 1/2. Gave me the same result. How we doing?
It's very tedious, but I got it.
Good. I agree. So is life, by the way. It's pretty friggin' tedious. Wait till you start working and take out the garbage. You get the oil changed in the car. Life is tedious. The sooner we accept and move on, the easier it will be. You will have some questions in Calc 2 that are like 10 pages long. And if you're going, oh man, I can't do it anymore, you got to maybe reconsider. You'll have projects that will last for 4 or 5 years if you're an engineer. I mean, they're still trying to cure cancer, right? How long has that been going on? So it's not about, it's about patience. It's about diligence. It's about neatness, being organized, enjoying. Yeah, Wilder said same thing. Why it's long, but I understand it. Good. Yeah, so we have to accept some things, not all things. Cool. Let's move on. New stuff. Unless anybody wants me to do anything else in terms of a difference quotient or a problem from the past at this point. We okay? Abraham's okay? Nice. So what we're talking about today is section 2.2. It should be really quick. It's only one particular homework section, and we're just talking about graphs of functions. Actually, 2.2 and 2.3 are similar. What we're going to do in 2.3 is we're going to take everything we know about a graph of a function, including this secant tangent problem, right? Secant line, a line through 2 points on a curve, tangent line, a line through 1 point on a curve. So we get to see more difference quotients today. So graphs of functions, this is 2.2, this is homework 7. It's pretty freaking quick. So, but let's look at a particular function. What is this? Y equals x e to the minus x squared. I mean, my curve is not perfect, but you'll still get the general idea. And so there's a couple of things on here that we should be able to find. What do you think? So first of all, when I give you a function, put it in your calculator, right? Even if you went to University of Maryland, they don't allow you to use calculators on tests or quizzes, but it doesn't mean when you're practicing, you're not looking at the graphs. And then hopefully eventually you're going to be able to see any particular graph quickly without having to use a calculator. But what do you think? What are some things I should be able to find from a graph?
Intercept.
Good. Yeah. X intercepts, Y intercepts, definitely, right? What else? Any particular point, like the one I put on, right? If I give you an
Yeah.
x, you should find a y. If I give you a y, you should be able to find at least an x.
Also maximum and minimum point.
Nice. High points, low points, right? And that's really our detail in calculus. We're really going to find. So like I could find this point easily in calculus by finding the slope first. Because what do I know about the slope there? When I'm at the top of the hill, my skis are parallel to the ground. So my slope is 0. So if I can find places where slope is 0, I can find high points, low points. Right? Which is, they're called mins and maxes. What else can I find?
The rate of change or slope.
Yeah, I definitely can find an average rate of change. And we're working on finding an instantaneous rate of change. The average rate of change is, I live in D.C. by the baseball stadium, okay? And I live 10 miles from campus in Tacoma Park. But it takes me an hour to get there, right? So, I mean, it's pretty bad speed. 10 miles in 1 hour. It's 10 miles per hour. But when I got hit with that speed camera, right, that one moment in time, right, my eyes are like, I was doing 65. So I got the ticket, right, but my instantaneous rate of change was 65 miles an hour. My average rate of change was 10 miles an hour. So this is our real problem with calculus, is, when I traveled to the moon, it took me 40 days, but when I was leaving the atmosphere of the Earth, I was going 7,000 miles an hour, right? So this is our big problem in calculus. What's happening in the long run? What's happening right this second, right now? I can't snap with my elbow on the desk. So that's definitely an interesting thing. What else? Something called asymptotes. So this particular curve has a horizontal asymptote of 0. In the long run, it will never hit the x-axis. It doesn't have any vertical asymptotes. X-intercepts, y-intercepts, points, highs and lows. Domain and range, you should be able to kind of see. It's not so easy to get the range from a graph. It's easy to get the domain from a graph. And we'll learn how to get the range. I'm not sure if there's much else we can get from the graph. But anyway, we're ready to look at problems. We've done all of this before, so this is really not anything new. So let's take a look at homework 7. So, like the first question is, if I tell you x is -6, right? Where's my mouse? Here it is. If x is -6, what's the height? 2, right? So, I mean, that's that kind of simple stuff. It's really kind of painful to me. And if I don't answer both questions, it won't let me go on, but I don't care. You get the idea. So look at the graph and find points. Here's a nice one. Answer the question. Is this point on the graph? If x is 2, what's the height? If the height is -1, what's the x? What's the domain? I'd like to answer what's the range? What are the x-intercepts and what's the y-intercept, right? So let's see what we do here. 2x squared minus x minus 1. So this particular section is pretty easy. So there's not a lot for me to teach here. But there could be things for me to answer here. So if I do something that you're unsure about, or if you get to a problem that's not clear, I'm trying to really kind of see where you're at times. Like, I don't care if I teach something. I want to see if you don't ask me anything or if you do ask me something. And there's nothing wrong with either one. The one I'm most worried about is if you don't answer, if you don't ask me anything, right? If you just haven't done anything, that's what I'm more worried about. But if you are doing the work and asking questions, and you get frustrated, I want you to ask, right? So please do that. All right. So I gave you this function f of x equals 2x squared minus x minus 1, and of course we're gonna graph it first, right? We get something like this. How do I know it opens up? Well, how do I know it's a parabola?
Because it's a quadratic.
Quadratic. And how do I know it opens up?
Because it's positive.
Positive leading coefficient. There's a positive 2 in front of the x squared, so it opens up. Positive people smile, right? Negative people frown. How do I know the vertex is in the fourth quadrant? How do I know the vertex is over here? Not so easy to answer that one, right? So in my picture, it's not perfect, but use your calculator, right? So I'm going to complete the square on this to get the vertex. So vertex form. So what I do is I factor out the 2 from the leading coefficient, the leading term. And when I do that, I get x squared minus 1/2 x. And it's really easy to see if you multiply that back through, you've still got the same function, right? So stop me when I start going too fast, okay? I'm now going to find my k term, which is negative 1/2, and get half of it. So half of k is negative 1/4. And I'm going to take that value and square it. So I get negative 1/4 squared is positive 1/16. And I want to add that on the outside and subtract it. Sorry, add it on the inside, subtract it on the outside. So I've got f of x equals 2 times x squared minus 1/2 x plus 1/16 minus 1. Oops, that's a 16. Sorry, 1/16 minus 1/8. And so I'm saying I've added 1/16 on the inside. I have subtracted the same thing on the outside. And where am I getting the 1/8 from? 2 times the 1/16 is what I've really added. So since I put that 1/16 inside, but I'm distributing by 2, I got to make sure I think about, after I distribute the 2, what do I really have there? 1/8, and I want to make sure I get rid of that 1/8. How are we doing there? Hello? Okay, nice. Thank you. Ryan and Elise are with me today. Sarah, yes? Nice. Thank you. Sarah gave me the side camera thumbs up. Elmer? Yvonne, yes. Rachel, yes. Aiden, yes. Brian, yes. Jarrett, Oscar, Benjamin, Manish, nice. Benjamin A, Benjamin C, thank you. Nice. So I'm going to keep going. Isaiah, thank you. Matthew, So I end up getting 2 times the quantity of x and half of k all squared. So that's x minus 1/4 1/4 all quantity squared minus 9/8. And so my vertex is actually coming from the opposite of this and the actual of this. So my vertex is at actually 1/4 comma negative 9/8. This is called completing the square, or writing a quadratic in vertex form. You might want to review that, right? So I can see my vertex is in quadrant 4. Nice. I can now answer domain and range. What's the domain of f? What x values am I allowed to put into this quadratic? Whew, killing me today. You're killing me, Smalls. Very good, class. All reals. And what about my range? What about the range of f? Well, I know it opens up, and I know the lowest point is the y value of my vertex, right? So it's going to be my vertex comma y to infinity. So in this particular case, it's negative 9/8 all the way up to infinity. And there's my range. Not so easy to get the range most of the time until chapter 3. Let's see, is the point 2 comma 9 on the curve? So the function is 2x squared minus x minus 1. And we want to know is if I put in 2 with empty parens, will I get 9? Question mark. And so I'm really trying to be as super careful as I can. Whenever I plug in, I'm trying to plug in with empty parens, right? Whenever I plug in, I'm trying to plug in with empty parens. So 2 times 4 minus 2 minus 1 equals 9, question mark. 8 minus 3 definitely does not equal 9. So 5 does not equal 9. That point is not on the curve. It's nice to double check all of this stuff kind of with your calculator. The calculator is very lame compared to Desmos, but I'll do some work here on Desmos with this one. So y equals 2x squared. Is it minus x minus 1? Minus x minus 1. And we had a vertex of minus 1/4. Is it 1/4? Yes, 1/4 comma negative 9/8. Feel very alone today in this class. I checked the point, what, 2.5? Is that right? Or 2.9? What did I check? 2.9?
Yeah,
2.9.
2.9, and it failed, right? 2 comma 9 failed. All right, look, that's working out pretty well right now. I also put in, I got my vertex form, which we're going to do quite a lot this semester. So y equals 2 times the quantity of x minus 1/4. Oops, come on, Robert. X minus 1 divided by 4 all squared. There we go. All squared minus 9/8. So you can see here, right now my curve is in red. When I plot this new one, it's in purple, and it covered it perfectly. So I know I've got the same curve, right? Domain is pretty obvious. range is pretty obvious once you have this vertex form. Good. What's next on my list? My phone is dying. What are the x values when f of x, when the y is -1, right? So what are my x values when y is -1? So f of x is 2x squared minus x minus 1. Find x when f of x is -1. So pretty simple, right? I'm just setting the function equal to the -1. This is all feels like a review, am I right? This feels like you've done this before?
Yeah.
Yeah, nice. Thank you, Sarah. So I get what? 2x squared minus x equals 0, and I'm going to factor. So it looks like I get x is 0 or x is 1/2. And of course I know that those are points, 0 minus 1 and 1/2 minus 1, right? So these are just points on the curve. And I can put them into Desmos as well. I'm sorry. Did I get that right?
Yeah.
X is 0, y is 1/2. Yes, that's right. Okay, just double checking. X is 0, y is 1/2. No, I didn't have that right. I got them switched, don't I? Oh, the y value is -1. Sorry. There it is, 0, -1, and 1/2 -1. There it is. And so I like Desmos because I can zoom on it as well, right? It's nice. You can see that. X-intercepts, right? Is that next on my list? Oh, domain, we did that already, right? We did domain and range. X-intercepts and then Y-intercept. So again, I know the function is 2x squared minus x minus 1, and I want to find out where the height is 0. So I want to find when 2x squared minus x minus 1 equals 0. You might have to review your factoring, so do that if you need to. For me, I know I'm going to do an AC method. So 2 times -1 is -2. The factors of -2 are 1 and 2, with one of them being positive, one being negative, or switched. And of course, the one that's going to get me my B value of -1 is +1 and -2. So I'm going to split the middle term, 2x squared plus 1x minus 2x minus 1 equals 0. So this is all that factoring we did in 8th grade or 9th grade or 10th grade. If you need to review it, please do so. I'm going to factor by grouping here. I can take out an x from the first 2 terms. I can take out a -1 from the second 2 terms. And I see a matching factor. So I know one factor is 2x plus 1. I know the other factor is the remainder of x minus 1. Right? And so there's my factored version of f of x. Right? And then from there I get my intercepts. So f of x equals 0 when x equals 1 or x equals -1/2. So I get x-intercepts of 1, 0 or 1/2, 0. That's what I was doing before. I was screwing up my whether I was getting intercepts or something else. And again, I can graph those. Right? Is this okay? Am I going too fast? I feel like I'm going too fast.
It's okay.
Okay.
Yeah, a little too fast.
Yeah.
Yeah, I agree. Just you gotta. I'm just I'm your Uber driver. I'm trying to see if you're gonna slow me down or not. If we were driving together in New York City, you'd be screaming at me because I drive like a maniac in New York City. Negative 1/2, right? Negative 1/2, 0, and 1, 0. Intercepts. Y-intercept I already have, right? X is 0, Y is 1/2, minus 1. Nice. So, I mean, that's it. Find points, find the intercepts, find asymptotes, right? All kinds of things like that. Look at the graph, find a high point, find a low point. It should be pretty easy. And I'm okay if you come up with something and say, I don't know what to do here. Please ask me. That's what I want you to do. So I think there could be a review on that vertex formula, the vertex version by completing the square. There could be some review you need to do on factoring, right? So it just gets built into those hours of, we meet 5 hours a week. I'm expecting you to be working 10 to 15 hours a week. Okay. So, and you have to just chip away. You have to get a little bit done every day. And this is why I'm really good at watching TV, because I watch it every day. That's why I'm really good at it. I know where all the channels are, everything. Right? So you just have to do a little bit every day. And some days are impossible. I get that. I'll try and slow down here, okay? But I felt like that mostly was review. But the next thing we're doing is even. So we're in 2.3 right now, okay? And it's more graphs of functions. But a couple of things that we're going to be talking about are even and odd functions. So symmetry, really talking about there, right? We're going to be talking about average rate of change or more difference quotients. And the last one, which I'm not going to get to today, is it's just points and intervals. Right, so this is homework. The first one is homework 8. And then homework 9. Homework 9 should be, you're ready to do it already. I've done everything there. And then homework 10 is here. I won't get to that today. And then we only have 2 more homeworks to do. We might finish Wednesday. I don't know. I'm planning on finishing Friday with chapter 2. So let's talk about even and odd functions real quick, right? If I don't get to homework 9, it doesn't mean you can't start it, because homework 9 is find 2 points on the curve, find the slope between the 2 points. Find the difference quotient, find the slope of the difference quotient, right? Find the secant line and use the difference quotient to find the slope of the secant line. So it's really nothing new there. They're just introducing it as a new way to look at the graph and to find points on the graph and et cetera, et cetera. I've already taught it. I've already taught you that whole section. So don't be afraid to jump ahead there if I don't get to all of it today. But I want to talk about even and odd. This should be something pretty new for a bunch of you. Am I okay here going forward? Anybody need me to go back and talk about something?
No.
The energy is so good today. Being sarcastic. It's Monday, right? You're tired. I was going to ride my bike to work today, but it's too tired. It was too tired. You get it? The bike. Too tired. I dreamt I worked at a Midas muffler shop last night, and I woke up exhausted. Thank you, Elise. She's giving me the same look my family does, like, oh, God.
What's the joke my dad would tell me?
Oh, yeah. If I didn't hate kids, I would be telling dad jokes, that's for sure. What do you call a bunch of kids in the blender? That's a dad joke for me. Red and white all over. No, I don't know. I'm sorry. I get a little sick sometimes. Okay, even and odd functions. So this is 2.3, even, odd, or neither. And there's something about this property of functions, and that's probably something I left off my list, right? I had asymptotes, I had intercepts, I had points, I had domain and range, and then I could talk about symmetry. So symmetry of functions. An even function would be something like y equals x squared plus 3. So when I have this fold on the y-axis, it's symmetric, okay? So this is an even function. And the key is if I put in opposite x's, so opposite x's, opposite inputs yield the same output. And this is something very important when we start doing integral calculus. When we start doing integration, there's something we can do with if our function is even, there's some shortcuts we can take. And so the key is that f of the opposite, if I put in opposites, I get out the same. So notice here my x's, my inputs are opposite, but the outputs, the function values, are still equal. So opposite inputs give me the same output. And this is our algebraic test. So I'm going to put in opposite x's and simplify and see if I get the same result. If I do, I have an even function. Odd functions will give me symmetry about the origin. So for example, y equals 1 over x is an odd function. And so the thing I'm looking for here is a double fold. I'm going to fold on the y-axis, and then I'm going to fold again on the x-axis, and everything should match up. The other way to think about this is, so I should have written that over here. Symmetry about the y-axis. Symmetry about the y-axis. And here I have symmetry about the origin. So the easiest way for me to think about symmetry or odd symmetry is a double fold. Fold on the y, fold on the x. Everything will match up. Or I could think about symmetry on the origin is I put a little nail in the origin, and then I can turn my function 180 degrees and it should look exactly the same. So after I rotate around the origin by 180, the graph is back to the original again. And so here, what do you think about if I put in opposites? If I put in opposites here, what happens? Very good, class. Opposite, they'll be opposite, Professor. Very good, class. So when you put in opposites, you're going to get opposite results. And so how do I write that? I like to say the opposite of f of negative x is f of x. When I notice that the insides are opposites here, right? Inside I have an x and a negative x. And outside I have a f and a negative f, right? So that's what I'm looking for. Looking for, if I put in opposites, I get opposite results for odd functions. And again, this is going to save us some time in calculus. It's also going to save us some time here. So meaning if I can, if I know I can put all positives in domain, I know and it's odd or even, I know I can put the negatives in as well, right? So that type of thought. Let's look at one that happens to be opposite, okay? Or odd. So now, if I say, is this function odd, all you have to do is the odd test. If I ask you, is it even, all you have to do is the even test. But if I say, is it odd or even, you might have to do both, and the answer still could be no, right? So if both of these fail, we know it's neither. And what is it? How do you say it? Is it either or is it either? How do you say it? Or no, is it neither or neither? What's the correct way of saying it? Neither or neither?
I say neither.
You say neither? So you can't pronounce the word at all, is what you're saying, Ryan?
It depends on how you pronounce.
No, but it is. What I'm asking is it neither or neither? If you say it's neither, that means I cannot pronounce the word.
That's just how I see it. Some people say neither.
Okay, so but if you're saying it's neither pronunciation is correct, then again, I cannot pronounce the word. It's a joke. All right, I know I'm not making anybody laugh today. I'll shut up. Okay, so it's the following function odd is my question. And I'm going to do f of x equals x over x squared minus 1. So it's the following function odd. What's the first thing I'd like you to do? If I give you a function, what's the first thing I'd like you to do?
Put it in the calculator?
Thank you. Graph it, exactly. So we're going to, as we do this, as we learn to do this for ourselves, we're going to start to get a better kind of visual library of things, right? And so we want that. We want to be able to say, well, what does it look like? So y equals x divided by x squared minus 1. Is that what I did? And look at this thing. Can you imagine putting a nail in at the origin and then turning the whole thing halfway around a circle? And does it match back up again? Right? Can you see that one? 2 of you can see that one. 3 of you can see that one. 4. Then 5. Then if I fold this way, right? And then fold again this way, does it match back up? And that's what it means to be odd. So some of you can see the rotation, some of you can see the fold, some of you can see both, some of you can't see a damn thing, and that's okay, because we still have the algebra to save us, right? We still have the algebra to save us. So let's see if we can do the algebra test to show that this thing is odd, okay? So we're thinking odd here. We're guessing odd. So first of all, we want to find f of negative x. And how do I do that? Everywhere there's an x, I put empty parens, and then I put my negative x in. You'll see upstairs, I keep the negative, but downstairs it changes, right? So there's the opposite. That's what I get from f of x when I put in a negative. Now I want to find the opposite of that. I want to find the opposite of f of negative x. So I want to find the opposite of negative x over x squared minus 1. And guess what? That negative distributes to the negative, and I get x over x squared minus 1. And notice what that is. That's the original function. And so there it is. That's what I wanted to show. That the opposite of f of negative x is f of x. So f of x is odd. It's not too bad, is it? Just want to look at another one of those and see. I mean, that's about as difficult as they get for the even and odd functions.
I have a question.
Yes.
I'm looking at the textbook and I've noticed that there's some that they show the picture. Is it also possible to tell whether it's even or odd by just looking at it?
Absolutely. So when it's symmetrical like this, like a butterfly, kind of, left side matches the right side, that's even. When it's symmetrical about the origin, so look at my hand here in quadrant 1, I'd have to see the same thing in quadrant 3. And this is that rotation by 180, right? So you can see that. The thing is, if I ask you a question like this, I'm always going to ask for the algebra, right? And so in calculus, we're going to learn limits using numbers, boring, by looking at graphs, boring. So it's always going to be the algebraic manipulation. Can you actually show it by, doing some algebra? That's what we want. We're trying to get you there. But we want the visual as well, right? We want to be able to see that. And that's what the book's trying to do. It's trying to get you to see how I would look at it in 2nd grade, how I would look at it in 8th grade, and then as we're moving into college, what's our sophistication level going to get to, right? And that's what we're trying to get you there. So I think the rest of these are all the same. What about this one, even or odd?
Even?
This one's even, and the secret of it really is the powers. If I only have even powers, I'm hinting at evened functions. If I only have odd powers, I'm thinking odd. It gets a little bit weird when there's fractions involved, so this one turns out to be odd. But because you can see if I put in a negative, the upstairs changes, but the downstairs doesn't, right? We just did one like this. So it's hard to see this one, but that's why we're going to graph it. We're going to think about it. We're going to graph it. We're going to do the algebra, right? Nice. I love it. Moving on. How much time we have? Oh, 6 minutes. It's going to be close. But that's okay. I probably won't finish the very next homework today, but you understand what to do. And I already said it. The next homework is about more with functions, but we're going to also add in this secant slope. We're also going to add in this difference quotient. We're also going to add in this average rate of change. All are the same. So we're only adding in one thing that we've already done. So this next homework should be pretty simple. Let's just go right to a problem and see how you do, right? So I'm going into homework. I'm going into homework 9, which I gave it a title of secant slopes. And of course, you know that what am I talking about? I'm talking about a function, right? And a line that's going through 2 points on the function. So this one, first one says find the average rate of change. What does that mean then? Plug in 2, find the y value. Plug in 4, find the y value. And then find the slope between the two. So very simple 8th grade version of it. What's number 3 say? Find the slope of the secant line in terms of x and h. Find the difference quotient. Then find a bunch of slopes that are average rates of change, meaning plug in an x, plug in an h. Plug in the same x, plug in a different h. Plug in the same x, plug in even a different h. Can you predict what's going to happen, right? And so let's go with this one. So let's see how much of question 5 we can get done. I doubt we'll get it all done, but it's not difficult. How we doing? Everybody okay?
Yeah.
Nice, Isaiah. Thank you. Thank you, Brian. Oh, I remember what it is from Office Space. Sounds like someone has a case of the Mondays. That's it from Office Space. All right, so we want to find the difference quotient for 2 over x. We want to then find the value of the secant line 3 times, right? And then try and predict what's happening to the slope of the secant line as h goes to 0. This is called a limit. And then we want to graph the secant line found in part C on the same window as the curve. Okay, I don't think I'll finish it all. In fact, I have 2 minutes left. I don't even know if I'll start it. But what do you care? So let's see what happens. F of x equals 2 over x. Let's see if we can get the difference quotient done in 2 minutes. Let me know when you got there. Anybody there? Is there anybody out there? Anybody get there? Nice. I did it really fast. I would never imagine you'd be able to do it that fast, but whenever I refrain from eating, I do things really fast. Get it? Anybody else? Nice.
Yeah.
Go ahead. Manish.
Yeah, I think.
Nice. All right, we're out of time. I'm sorry. I refuse to keep you late. So we'll finish it on Wednesday. Have a great Monday. Let's be sleeping right, eating right, exercising, being kind to people, doing math homework. Oh, you had me until there, Robert. Right. See you Wednesday.
Thank you.
Thank you.
Have a nice
Have a good day,
Thank you.
Professor.
Quick question.
Yes.
Are we getting a review packet or something for the test?